Prepare to be amazed as we unlock the treasure trove of exceptional machines and tools that are redefining the way we approach agriculture. In this video, we reveal a collection of groundbreaking innovations that showcase the unparalleled capabilities of modern farming technology. Discover the accuracy and effectiveness of GPS-guided precision sprayers. Witness the efficiency and speed of automated citrus fruit harvesters. Explore the power of hydrological monitoring systems in water resource management. Marvel at the precision and safety provided by robotic sheep shearing machines. And experience the sustainability and reliability of solar-powered electric fences. Together, they represent a revolution in agricultural practices where precision, automation, and renewable energy intertwine. Number 5. GPS-guided precision sprayer. The term GPS-guided precision sprayer refers to a specialized agricultural sprayer that uses GPS, global positioning system technology, for the purpose of applying pesticides, herbicides, or other agricultural chemicals in a precise and targeted manner. These sprayers are known as GPS-guided precision sprayers. Utilizing global positioning system, GPS technology allows for a more accurate determination of the location and position of the sprayer inside the field. The sprayer is fitted with global positioning system, GPS, receivers, which can detect the sprayer's precise location by receiving signals sent from satellites, so enabling accurate navigation and steering. Precision sprayers that are directed by GPS are frequently equipped with the ability to apply varying rates. By integrating GPS data with mapping and prescription software, the sprayer is able to adjust the rate of chemical application in response to specific field conditions, such as the type of crop being sprayed, the state of the crop, the number of weeds present, or the variation in the soil. This ensures that the application is focused and efficient, thereby optimizing the use of chemicals and decreasing their impact on the environment. Precision sprayers that use GPS navigation almost always come with section control features built in. The sprayer is made up of a number of different pieces, and each of those portions has its own spray nozzle. The sprayer automatically switches on or off the necessary parts based on the data provided by the GPS receiver. This helps to reduce the amount of chemical that is wasted in areas that are not the intended target. Number 4. Automated citrus fruit harvester. The term automated citrus fruit harvester refers to a specialized piece of machinery or robotic system that is designed to automate the process of harvesting citrus fruits, such as grapefruits, oranges, or lemons. Typically, automated citrus fruit harvesters include either a robotic arm or a specialized harvesting mechanism that is meant to carefully separate ripe citrus fruits from the trees. These harvesting mechanisms can either be robotic in nature or mechanical in nature. The grasping and detaching of the fruits is done without causing any damage thanks to the robotic arm, which imitates the motion of a human hand. Vision and sensing systems are frequently incorporated into automated harvesters so that they can detect and recognize ripe citrus fruits. These systems identify and analyze the color, size, and maturity of the fruits using cameras, sensors, or other forms of machine vision technology. The harvester is able to pick only the ripe fruits, leaving the unripe ones on the tree, and selectively pick only the ripe fruits. Advanced algorithms and software are utilized by automated citrus fruit harvesters in order to detect and choose the fruits based on the criteria that have been established in advance. Real-time analysis of the acquired photos or sensor data is performed by the system in order to identify the fruit's quality and whether or not it is ready to be picked. In order to navigate across the orchard and find the specific trees, many automated citrus fruit harvesters make use of global positioning system, GPS, or mapping systems. These systems give the harvester the ability to follow predetermined courses or routes, which ensures that the orchard is covered thoroughly while causing the least amount of harm to the trees possible. Many automated citrus fruit harvesters incorporate mechanisms for gentle handling and sorting of the fruit after it has been gathered. They may use vibration devices, brushes, or conveyor belts to move the picked fruits without inflicting any bruising or harm to the fruit. The fruits can be separated into groups according to their size or quality using sorting systems, which makes packaging and future processing much simpler. Number 3. Hydrological monitoring system. A hydrological monitoring system is a collection of tools, sensors, and devices that are used to gather and analyze data pertaining to water resources. This data may include the amount of water present, its quality, and the direction in which it is moving within a particular region. The numerous metrics that are related to the quantity of water that are monitored by hydrological monitoring systems include stream flow, river levels, groundwater levels, precipitation, and snowfall levels. These data contribute to the evaluation of water availability, the monitoring of changes in water resources, and the support of choices pertaining to water management. In addition to monitoring hydrological parameters, water quality metrics such as pH, temperature, dissolved oxygen, turbidity, conductivity, and nutrient, pollutant, or toxins concentrations are also monitored by hydrological monitoring systems. These statistics are essential for determining the quality of the water, locating the causes of contamination, and making certain that the water is safe for consumption for both human and ecological reasons. In order to collect spatial data on water resources, hydrological monitoring systems frequently make use of remote sensing technologies. Examples of these technologies include satellite images and aerial photography. Telemetry systems are utilized to communicate real-time data from several monitoring stations to a centralized location. This enables continuous monitoring as well as prompt decision-making. A wide variety of data-gathering platforms, such as weather stations, stream gauges, groundwater wells, and automated sampling equipment, are utilized by hydrological monitoring systems. These platforms are carefully located in a variety of places so that they can collect data that is representative of the area and provide an in-depth understanding of the hydrological processes. Data obtained from hydrological monitoring systems are subjected to analysis with the use of specialized software and various modeling strategies. In order to analyze the data, evaluate the patterns, and anticipate the future water conditions, statistical analysis, hydrological models, and data visualization tools are utilized. Number 2. Robotic sheep shearing machine. A robotic sheep shearing machine, also known simply as a robotic sheep shearer, is an automated equipment designed to shear the wool from sheep, either in place of or in addition to human shearers. Shearing machines for robotic sheep typically consist of either a robotic arm or a specialized shearing mechanism that is designed to quickly and safely extract wool from sheep. Both of these components are robotic. The motion of a human shearer is imitated by the robotic arm, which then shears the wool from the sheep using combs or blades without endangering the animals in any way. Vision and sensing technologies are frequently integrated into robotic sheep shearing equipment. This helps to ensure that the sheep are shorn precisely and accurately. These systems make use of cameras or sensors to determine the size, shape, and curves of the body of the sheep. This enables the robot to tailor its shearing activity to the specific requirements of each individual sheep. Robotic sheep shearing machines may contain devices for automatic wool gathering, which occurs after the shearing process is complete. These machines are able to collect the sheared wool, clean it by separating it from any debris or impurities, and package it for either further processing or sale. The humane treatment of the sheep and their overall well-being is given the utmost importance by robotic shearing equipment. They are constructed in a way that reduces the amount of anxiety and discomfort that the animals feel throughout the shearing process. It is possible to design the device with various safety measures, such as sensors or pressure-sensitive mechanisms, to avoid injuring either the sheep or the user. When compared to traditional manual shearing procedures, robotic sheep shearing robots offer enhanced efficiency and a reduction in the amount of labor required. They are able to perform their duties without becoming fatigued and may need less assistance from humans. Sheep shearing operations may benefit from decreased labor costs and increased production as a result of this. Some robotic sheep shearing machines may be adjusted to accommodate a wide variety of sheep breeds, sizes, and types of wool. They can be programmed to alter shearing procedures and parameters based on specific requirements, which ensures that optimal shearing outcomes are achieved for various qualities of sheep. Number 1. Solar-powered electric fence. A solar-powered electric fence is a sort of fencing system that uses solar energy to power the electric charge. This type of fencing system is an excellent means of containing animals or protecting crops from wildlife. A solar panel is the component of a solar-powered electric fence system that is responsible for collecting sunlight and transforming it into electricity. In most cases, the solar panel is fastened to the top of a fence post or is fixed nearby in an area that receives a sufficient amount of sunshine. A rechargeable battery, which is attached to the solar panel, is used to store the electricity that is generated by the solar panel. The charging of the battery is controlled by a charge controller, which prevents the battery from being overcharged or discharged and ensures that it functions at its optimum level. The energizer, sometimes referred to as the fence charger or controller, is the most important component of an electric fence that is fueled by the sun. It is powered by the battery, and it converts the power it gets from the battery into pulses of electrical energy. These pulses are transmitted through the wires or strands of the fence, and when they are touched, they produce an electric shock. This deters animals from trying to climb the barrier. Conductive materials, such as high-tensile steel or aluminum, are used to construct the solar-powered electric fence, which comprises of wires or strands of the material. Insulators are utilized in the process of securing wires to fence posts and preventing electrical leakage to the ground. Insulators are also utilized so